In this video, we are going to start to work with logarithms. So the first question is, how are logarithms used? The first answer to that is to condense a large scale to a manageable numbers. So one of those large scales is the magnitude of earthquakes. Earthquakes are measured by how much energy they release. They release a huge amount of energy, numbers that we can't even really wrap our brain around. And so those numbers are reduced to manageable numbers via the Richter scale. The same is true with the intensity of sound. The faintest noise has a very, very small decimal for its intensity. And so those numbers are converted to manageable numbers called decibels. The pH scale is another example, which is a measure of the hydrogen plus ions. These are numbers that are hard to work with, but we reduce it to a pH scale, which is numbers that are easy to work with. Another application would be the brightness of a distant star. Same idea, taking really, really big numbers and condensing them to numbers that are manageable. We'll see this as we look at the first three examples throughout the lecture this week. Second way that logarithms are used are for data regression. So we've already seen that a logarithm creates a concave down curve. And so when we want to find an approximation for data that has a concave down curve, we can use a logarithm. And then the final way is based on the fact that they are inverses for exponentials. So we can solve an exponential equation using a logarithm. And again, throughout the lecture, we'll go through quite a number of examples of that use. So I'd love for you to grab your calculator. If you need to pause the video, do. But I want us to find and try out the buttons on our calculator and just see how the numbers that we get using the logarithm make some sense. So there are two types of logarithms, the common log, which is when we use the LOG button on our calculator, and the natural log, which is when we use the LN button on our calculator. And it will really depend on when your calculator was made, if you have uppercase ln or lowercase ln, but they have the same meaning. So going back up here to common logs using the LOG abbreviation and button on your calculator give exponents for base 10. So this is what our number system is based on. So in our number system, as you see over here in the chart, if we have 10, that is equivalent to 10 to the first power. So on your calculator, if you would type log, so that button should be right beside the number 7, and then you type 10 and hit enter, your calculator gives you 1 because the exponent is 1. Now we know that 100 is 10 squared. So on our calculator, if we take log of 100, it's going to give us an answer of 2, because 2 is the exponent for 10 that gives you 100. So I want you to pause the video and write the exponents or the answers for log of 1,000, log of 10,000, and the last one might stretch you a little bit, but log of 1/10. So go ahead, pause, write in what you think the answers are, and then I'll go over them. So if I look at 1,000, I know that this would be 10 to the third, which means the exponent is 3. So that means that the answer to log of 1,000 is indeed 3. So if I then have 10,000, that would be 10 to the fourth power, and so the log of 10,000 is 4. Now, 1/10. This was one of our rules for exponents. The 10 is in the denominator, so if I move it up to the numerator, this would be 10 to the negative 1 power. Because we know a negative exponent made us have the reciprocal and move that element to the other part of the fraction. And so then if I would take log of 1/10, I would expect an answer of negative 1 because that is the exponent that gives us 1/10. Now, on your calculator, over here in the typing, I would like you to try log of 50. So the log button's beside the 7, type 50, hit enter, and you'll get approximately 1.7. We could keep a few more decimals for this, so I'm going to write it down as 1.699, just to be a little bit more accurate. And so if I look over here, 50 is between 10 and 100, so the exponent is between 1 and 2. Now, we know that this answer is an exponent, so if I would take 10 to the 1.699, I should get very close to 50. So try it. So on your calculator, 10, use that caret key, and type in 1.699 for the exponent, and my calculator gives me 50.003. So to 2 decimals, it's exactly 50, but if we go out far enough, we do get an approximation because we did round our 1.699. So what I want you to see here is what this title is. The logarithmic function gives you the exponent. With the common log, it is the exponent for a base of 10. Now, with the natural log, it is the base for e. And we used e with a number of financial calculations at the beginning of the semester when we were practicing working with formulas. E is used for lots of things that grow or decay continuously. And so it can have financial applications, but it can also have applications in the real world, specifically in nature, things that are growing or decaying continuously. So on our calculator, we have this ln button. It's right beside the number 4. So I would like you to type ln, natural log of 40 on your calculator and hit enter. And again, we'll round to 3 decimal places, so that would be 3.699. 3.689. And so again, this is the exponent. However, since it's natural log, it's the exponent for e. So e to the 3.689 should take me back really close to 40. So in order to type that, I'm going to do second and the ln button. And then I'm going to type my exponent, 3.689. And it gives me an answer on my calculator, 40.004. And again, you can see with a little bit of rounding we did with the answer, this is not exactly 40, but really close, even to 2 decimal places. It would be exactly 40. So takeaway, the logarithmic functions give you the exponent. If you have the word log, it's for base 10. If you have the abbreviation ln, it goes with base e. Now, I always find my calculator button super helpful here because if I look at the log button and I look at the blue font for the second, it shows me 10 to the x. If I look at the ln button, look at the blue font above it, it shows me e to the x. So it's even connected with those calculator buttons what base to use.